In this video, your objective is to be able to say that you can identify rate of change based on graphs or even stories. Now, the first thing you'll have to remember is that rate of change is how much the y value grows for each unit of the x value. So here we have three different graphs, and we can see that for the first graph, um, our x-axis is measuring time in seconds. And even though the first pinpoint we have is at 10, we're more concerned about how much we're growing every 1 second. So we can see in a distance of miles that this person has actually grown 5 meters per second. So our rate of change is actually 5 meters per second. Now in this next example, we're actually fortunate enough to have the first data point labeled for us. And again, we have to look right here for our rate of change. And in this example, we'll see that we travel 20 kilometers per hour. So for every 1 hour that we jump up another 20 kilometers. So actually in the second hour, we're actually at 40 kilometers. And lastly, we are still measuring distance in miles. Our time is in hours. And if you'll notice, we've actually, at the point 0, we're already at 5 miles. So we're not really measuring any time that's gone by until we've made it to 5 miles. So here you can see that there's only a difference of 10 miles between each data point. So from here we're at 5, then we go to 15, then we go to 25, then we go to 35 each individual time. So you have to watch out for this point right here. This is 10 miles every 1 hour, or per hour. So again, you want to check how much are you growing by each individual step. Now, as far as stories are concerned, or finding out the rate of change based on an equation or a story, the first thing you want to see is how much are you growing, how much is your dependent variable changing based on how much your independent variable is changing. So in this example, we see that Jessica is ordering food for her friends. Oops, this should say her. For her friends, the variable m stands for money, and the variable f stands for friends when we have this equation. So I know that the money is reliant on the number of friends, and your biggest clue for your rate of change is checking the coefficient, because your coefficient will always tell you your rate of change. So this says that actually Jessica is paying $14 per friend. So our rate of change is actually 14, and that tells us that for each friend that Jessica has and she's ordering food for, she's paying $14 for that one person. Now, the next question asks us, what does this other value represent? Now, this is additional money that she has to pay. This is our constant. So remember, we have the equation that m is equal to 14f plus 20. And I can see that while she's paying $14 per friend, we have an additional $20. So you can say, maybe you can say that it's $20 for tax, or it's $20 for something she ordered for herself. But we know that even though the rate of change is 14, that we have this extra $20. So I'm going to write the $20. Oops. The 20 represents the constant which can be tax, or food for herself. Now we have one more example. Kenny's trying to lose weight. The variable m stands for months, and the variable w stands for his weight. So we want to figure out what the rate of change and what the rate of change is and what it represents. Now again, we should remember that our rate of change is negative 12 right here because this is our coefficient. It's important that you remember that negative because this is telling us that Kenny loses 12 pounds each month. So because we have a negative value, that means that we're going down by 12 pounds, or that Kenny is losing 12 pounds each individual month. Now, what the other value represents, and remember, you have to read the story a little bit to figure this out, and you can assume that the plus 300 means Kenny originally weighed 300 pounds. And because he's losing that 12 pounds a month, he's got to be taking it away from somewhere, and that's the 300 pounds. I hope you're able to say that you can identify rate of change from graphs or tables or even stories. If you have any other questions, as always, please feel free to email me.